Hi everybody, Mr. Vidich here. Today we're doing lesson 2 of linear systems. Okay, so let's just jump right into it and do this example. I'll help you out with this exploration sections. If you want to try it on your own, go ahead and pause the video and then jump in later. Okay, so as part of a high school work experience course, 3 students have been placed in 3 different burger restaurants. Deja has been placed at Burger Shack, Shelly has been placed at Big's Burgers, and John has been placed at Burger Heaven. So detailed below are the first 2 orders taken by each student and the total cost calculated by the student for each order. Okay, so let's see what happened at Burger Shack. So at Burger Shack, the first order was for Deja was $28, and that was for 4 burgers and 2 salads. The second order was $34 for 6 burgers and 1 salad. Okay, Big's Burgers, Shelly paid for or charged $18 for a burger and 3 salads and $54 for 3 burgers and 9 salads. And then John, finally, Burger Heaven, charged $32 for 2 burgers and 4 salads and $42 for 3 burgers and 6 salads. So we want to, again, these are obviously the goal here is to determine how much a burger costs and how much a salad costs at each restaurant. Okay, so the way we do this is let me just blow up the screen a little bit. So the way we do this, again, we're gonna use some labels here, variables to represent our burgers and salads. And the most common ones we always see is X for X is going to be the cost of a burger, and Y is going to be the cost of a salad. So it says here, write a system of equations for each scenario. So let me just help you out with this one here. So let's go Burger Shack. So the whole price was $28. So I'm going to just go equals 28. So how many burgers, how many burgers were there? There was 4 burgers in the first order, so 4 burgers. So what's the cost? Well, 4 burgers. And if each burger costs X amount of dollars, it's just going to be 4X plus the salads, and there are 2 salads, and the cost of each salad is Y. So that's the first order. So 4 times the price of a burger plus 2 times the price of a salad should come out to $28. And then the second order was $34, and that was for 6 burgers and 1 salad. So 6X plus Y. At Big's Burgers, we have $18 for 3 salads. For 1 burger and 3 salads, and $54 for 3 burgers and 9 salads. So 3X plus 9Y. Okay. So again, the key thing is that we're defining that the X and Y are the cost in dollars per item. Okay. So the finally Burger Heaven, John paid $32 for 2 burgers, so 2X, 2 times the price of burger plus 4 times the price of a salad, which is Y. That's what we're trying to find out, how much each one costs. And then finally $42 he paid for 3 burgers and 6 salads. Okay, so consider the equations for Burger Shack. Write each equation in terms of Y. So let's go ahead and do that first. Just rearrange this. So it's going to be 2Y equals negative 4X plus 28. Divide both sides by 2, and we get negative 2X plus 14. That's for equation 1. And then for equation 2, that's equation 1. And for equation 2, we're going to get Y equals negative 6X plus 34. Okay. And we're going to use a graphing calculator to go ahead and graph this. Let me pull it up here. So we have Y equals negative 2X plus 14 and negative 6X plus 34. Okay, when I hit graph, now when you go zoom 6, your standard window is probably not going to capture your intersection, but let's try it out anyway. Yeah, okay, so there's one. Oh, it does. Okay, so we're actually okay. So in case it didn't, we'd have to adjust our window, but we got lucky in this case. So I'm going to go ahead and calculate the intersection And where these 2 points intersect is going to be the solution, obviously, of our system. And that point is x equals 5, and I forgot it already. X equals 5 and y equals 4. So y equals 4, and there's your answer. Okay, that is the cost of this will be the burger. Okay, that's $5 for the burger, and $4 for the salad. Okay, so this is a very useful tool that we have in order to calculate various variables, real world variables, such as the cost of a burger and the cost of a salad. Okay, repeat part B for Big's Burgers. Can you determine the cost of a burger and the cost of a salad? Okay, let's go ahead and do that for Big's Burgers. So again, negative. Let me do that again. So now we're doing. I'll do it in red here. Okay, so 1 and 2 there. 3y equals negative x plus 18, and then we have y equals negative x over 3 plus 6. That's the first equation, and the second equation is going to be 9y equals negative 3x plus 54. Divide both sides by 9, and I get negative x over 3 plus 54 divided by 9 is 7, or rather 6, excuse me. So one of the issues, well, look what happens now. It says here, can you determine the cost of a burger and the cost of a salad? Well, these two lines, these two equations are the exact same equation. If you look and if you graph these, they have the same. I can do this one manually. 1, 2, 3, 4, 5, 6. There's the y-intercept for both of them, and the slope is negative 1 over 3. So down 1 over 3. I'll eyeball this one. So there is no solution because both of the lines, both of equation line 1 and line 2 are overlapping lines. They lie right on top of each other. So basically the cost of a burger and the cost of a salad you can't really get because there isn't an intersection point. Okay, I hope that makes sense, because again, there isn't one solution. We actually have infinite number of solutions, and that means infinite number of solutions means we have infinite possibilities for the cost of a hamburger and the cost of a salad. All right, let's go ahead and do this last one for the last burger place. So let me just go ahead and rewrite it over here just so I don't have to scroll up and down here. So that's going to be 4y equals negative 2x plus 32. Y equals negative 1/2 x plus 8. That's equation 1. That's 1. That's 2. And then equation 2 is going to be 6y equals negative 3x plus 42. Y equals negative 1/2 plus 8. Okay, and 7. This is 7. Yeah, almost made a mistake there. So I made a calculation. So our two equations for the last one, if you notice, they have slightly different y-intercepts, but they have the same slope. So what you end up having when you graph this, what's the y-intercept? 7 and 8. So let's do 8 here. Let's say that's 8. So, and the slope is negative 1/2, which means it's 1 down 2 over, 1 down 2 over, something like this over here for the first equation. And the second equation is going to have y-intercept at 7 and the same slope. Well, if it's the same slope, we know from the previous unit these lines are going to be parallel. And again, the problem with this one says here, explain how you can tell the student must have made an error in the last one of his calculations. Well, you can't actually determine the cost of the salad or the hamburger because these lines are parallel and there isn't a solution. So when you have parallel lines, you can't get any solutions, and therefore you can't really determine that. So what this is telling you is that this student must have made a mistake somewhere when they were doing their bill or whatever, they were charging their customer, because this basically won't make sense. $32 for 2 burgers and 4 salads, and then $42 for 3 burgers and 6 salads doesn't make any realistic sense. You you couldn't have the same price for the burger and the salad, and for those two things to be the same. In other words, no numbers, because there isn't a solution, no price for a burger will work out. For example, let's just throw some numbers out there. Let's say if the burger is $6 and the salad is $4. So $6 times 2 is 12. 12 plus. So let's make this 5 here. So $6 times 2 burgers, that's $12, and $5 for salad, that's $20. That's 32. But then that should also work for this next one, and it doesn't, because 6 times 12, or 3 times 12, 3 times 12 is 36 for the burgers, and 6 times 5 for the, sorry, not 12, 6 here, so that's 18 for the burgers, and then 6 times 5 is 30, and that should add up to 42, but it doesn't. So this student must have just made a calculation mistake. Okay, let's move on here. And again, just from judging that, what we just did in the last section, I'm going to skip this section over here and basically kind of go right to this table over here, where the number of solutions, again, we can have one solution, none, so 0, 0, and infinitely many. Those are your options here. Again, you can have, those are only for lines, right? If you have curves, if you have something like this, that's going to have 2 solutions, but we're only dealing with straight lines here. So the graphical example of one solution, well, that's the one we've seen many times now. So you can just have maybe 2 lines that intersect like that, and so your one solution is going to be here. The slopes and the intercepts are both different. Okay, so the slopes and the intercepts are both different. Okay, all right. Now infinitely many. Okay, well, let's look at this one. So for zero solutions, the lines must be parallel. In other words, we're going to have something like that. Parallel lines which never touch, their slopes are equal, and their intercepts are different. For infinitely many solutions, well, for infinitely many, the 2 lines have to be on top of each other. They have to be on top of each other, and again, every solution works, right? They share all the coordinates, which means their slopes and their y-intercepts and x-intercepts are the same. Okay, so both slope m and y int and x int are the same. Okay, all right. Let's do a few more examples down here. So without graphing, analyze each system to determine whether the system has one solution, no solution, or infinitely many solutions. So based on that rule from the table, we can go ahead and do these questions here. But the first thing you need to do is rearrange this into y equals. So that's going to be y equals negative 3x over 5. And I'm doing this in my head here, plus 3. And then look what I noticed right away. I noticed that the slopes are the same for my 2 lines. And the y-intercept is different. So if I graph this, although it says without graphing, but for the first couple times you do this, you want to, if you can't visualize this, you might want to graph it. This line is going to be something like this, and this line is going to be something like this. So we have parallel lines because they have the same slope. So how many solutions? No solutions. So 0 solutions, or none, or whatever you want to write. Okay, if I rearrange this one, it's going to be y equals x over 4, which is 1x over 4. Divided by, or plus 2, I should say. And look at that. Well, that's exactly the same as that, which means the lines are one of the same. So there's 2 there. You're going to have something like that for both lines. So you're going to have infinite number of solutions. That's a math symbol for infinite. All right, for this one, we have y equals negative 7x plus 12, and we have y equals x over 6 plus 5 over 6. I can tell that their slopes and their y-intercepts are different, so we're only going to have one solution here. Okay, I'm trying to move quickly here because I want to get to this graphing example here. All right, so let's just do this last one here. So we have, again, this is a word problem, and now we're finally getting into some, practical examples here. So let's go ahead and do this. We have a high school students council decided to sell sweaters. The cost of designing the sweater includes a fixed cost of $600 plus $5 per sweater. Okay, and there's that equation down here. So they use the letter D for cost, and it's $600 plus 5 times N, where N is the number of sweaters. Okay, the Students' Council plans to sell the sweaters for $25 each. The cost revenue can be represented by the following system of equations, where D represents the dollar and N represents the sweaters. Okay, so again, we have a system here. This is the cost to make the sweaters, this first equation, and this second equation is the revenue. Okay, because they're charging 25 bucks a pop here, 25 bucks for each sweater. So without using a graphing calculator, to graph each equation, to use a graphing calculator and sketch on the grid here. So let's go ahead and pull up our graphing calculator, and first of all, I'm going to clear these two equations. Okay, so we have 600, and just because it's yx over here doesn't mean that you can't use this. Whatever variable, it doesn't matter what the variables are, you can still put them into your y equals here, except this time D is going to be your y here, so and your N is going to be your x, so plus 5x and 25x here. So if I go ahead and graph this, it's not going to show up here, or at least the intersection is not going to show up here because these numbers are so big. I get some crazy window like this, so I have to mess around with the window here in order to get this intersection. So first thing I'm going to do is I'm going to just go right ahead and increase, because of this 600, that's the y-intercept, so I'm going to go ahead and make my y max 700 and see how if that changes anything. Okay, the other thing I don't care about is the negative x values, because that would represent the negative number of sweaters, and I don't really care about that, so I'm going to make that 0. Sorry, make that 0, and I'm going to maybe sell, because N is the number of sweaters. Let me see what happens when I sell 100 sweaters. I'll make the scale 10, and I'll make the scale here 100 for the cost. Okay, so I'm getting some not quite the best window yet, so I'm going to increase my Y max maybe to $2,000, because that is the revenue. Okay, let's see what happens now. All right, that's probably going to be a lot better. Okay, there it is. So I'm interested in this intersecting point right over here. We'll use the graphing calculator to graph each equation and sketch each graph on the grid. So I'm going to let you guys go ahead and do that. Here is their window goes up to 1,050, so you can change that around. Mine went to 2,100, so it's double the size. And it says how much profit or loss is made if 20 sweaters are sold. Okay, if 20 sweaters are sold, what we're looking for here, again, if 20 sweaters are full, so I'm going to go ahead and second function calculate. I'm going to put 20 into both equations. So let's go ahead and calculate that. Find the value of 20, and I get, so that my first graph, that's the top one. So when I put in, I can actually do this algebraically just to be a little more precise here. So here is my D equals 600 plus 5N. That's my cost. So 600 plus 5, and then N was 20. So that makes it 100. So that's going to be $6,000 is going to be my cost of making. Oops, that's terrible math. 600 plus 100 is 700. Okay, so the cost of making 20 sweaters is $700, and then I'm going to go ahead and do my revenue equation. The revenue is going to be 25 times the number of sweaters. Well, for 20 sweaters, that's going to be 500. So my revenue is 500 and my expenditure is 700. So how much profit or loss? Well, I'm losing, I have a loss of $200. And then if 50 sweaters are sold, so again, I'm going to put in a 50 here. So it's going to be, this is the revenue, 600 plus 5 times 50, and then D equals 25 times 50, so that would be the revenue. Again, the cost here would be 600 plus 250, so the cost would be 850. All right, and then how much money I make here, that's $1,250. So again, now this time I make a profit of $400. So that's what happens when I sell 50 sweaters. Okay, to break even, the break-even point is the point where there's no profit or loss. Well, the break-even point is where these two lines intersect, right over here, okay, because I'm neither making money nor losing money. So this is why this being able to solve the system is good. Okay, so again, I'm going to just go ahead and calculate that point. Second function, calculate 5 intersection, and that would be 30 sweaters and $750. So 30 sweaters, N equals 30 and D equals 750 is where I break even. If all 850 students in the school purchase a sweater, how much profit will the Students' Council make? Well, I'm going to let you go ahead and do that one by following the same steps I did up here for 50 sweaters and 20 sweaters. Okay, thanks for watching, guys, and I'll see you next time.